Bismillahirrahmanirrahim. Now we discuss a very important result. Example number 6, a basic result. Integral of this type of the function along any closed path. We have already discussed this example in the previous exercise 13.1 when you have a specific closed path. Now here in this example the path is arbitrary closed path, as this is an arbitrary closed path. मतलब आपका ये ऐसा पाथ है जिसके बारे में आपको नहीं मालूम कि ये क्या है, राइट. नाउ वी वांट टू फाइंड द इंटीग्रल ऑफ दैट function, same function as in the previous exercise, along this arbitrary path, and this path is closed. Now we used here Cauchy integral theorem for doubly connected domain. We consider this function is not analytic when m is negative, right? When m is negative, then this term is in the denominator and the function is not analytic as g naught. So at z naught function is not analytic, so we consider a circle of any radius rho at center z naught, at center at that point where the function is non-analytic. हमने ये खुद से कंसिडर किया ताकि हम डबली कनेक्टेड वाला थ्योरम लगा सकें, क्योंकि जो पहले आपने एग्जांपल की थी एक्सरसाइज 13.1 में, वहाँ पे क्लोज्ड सर्कल एग्जिस्ट था ऑलरेडी, राइट. नाउ द आर्बिट्रेरी पाथ इज एग्जिस्ट एंड यू वांट टू फाइंड द integral of the same function along that arbitrary path. How can you find? Now you know that when m is positive, m is 0, then that function is analytic. So Cauchy integral theorem, by Cauchy integral theorem, answer will be 0. This is the very clear result. So means when function is given as, if m is 0, m is positive, then that function is analytic and path is closed. Any closed path, कुछ भी हो आपको, no concern for that one. Any closed path, then answer will be equal to 0. So when function is analytic and path is closed, then answer will be 0. Now if m is negative, and if m is negative and less than -1, then how can you solve? You know that in the previous exercise you given a definite circle, and now here is the arbitrary path. So at point z naught at center and consider a circle of radius rho. So with the help of Cauchy integral theorem for doubly connected domain, find the integral along this path. If you want to find the integral along this path, then find the integral along this path. These both are equal. This is the Cauchy integral theorem for doubly connected domain, right? So means we consider the radius of with center with radius O and center z naught, and this one c is equal to 0 to 2 pi and by path. Now use the by path formula. What is this one? And you know z minus z naught modulus is equal, this circle is equal to z minus z naught is equal to radius. So z minus z naught is equal to rho radius e raised to power iota t. Means this one is z minus z naught is equal to rho. When you want to write in parametric form, z minus z naught is always equal to rho e raised to power iota t. So z is equal to z naught plus rho e raised to power iota t, and z dot, this one is z dot. Z dot is equal to rho iota e raised to power iota t, and z dot means derivative of z, right? And now what is the by path formula? If you consider this path, then integral along c z minus z naught m dz is equal to, now we consider this path because the integral along this is equal to integral along this, right? Now this circle is 0 to 2 pi limit, and z minus z naught is equal to rho e raised to power iota t, and substitute here raised to power m, then z dot t is equal to this one, substitute here, and dt. Some constant terms outside, then you get this one and integrate this one. Now e raised to power 2 pi m plus 1 iota, you can write it cos of 2 pi m plus 1 plus iota sine of 2 pi m plus 1, and 2 pi multiple means cos of 2 pi multiple as well 1, and sine 2 pi multiple anything is equal to 0. You know e raised to power 2 pi m plus 1 iota can be written as cos of 2 pi m plus 1 m plus 1, I think t missing here, right? Now see, cos of this one is cos 2 pi m plus 1, not missing t here, right? This one t, substitute 2 pi here, e raised to power 2 pi into m plus 1 iota is equal to cos of 2 pi m plus 1 plus iota sine of 2 pi m plus 1. Cos 2 pi multiple of any integer is always equal to 1, and sine of 2 pi multiple of any integer is always equal to 0. So 1 minus 1 is equal to 0, so answer will be 0. So for all values when m is less than -1, then answer will be 0. Now we consider if m is equal to -1, then substitute just substitute m is equal to -1 in the very first step of the previous one. So you write here, मतलब जो लास्ट स्टेप आपने किया जहाँ से ये सॉल्व करना शुरू किया था उसके फर्स्ट स्टेप में m को पुट कर दे, राइट. एंड आफ्टर दैट वन, आफ्टर सिंप्लीफिकेशन यू गेट जस्ट ओनली 1 here, and then integrate with respect to t, then you get t, and applying upper lower limit, then you get 2 pi minus 0. We directly solve here, and the answer will be 2 pi iota. Means when you want to find the integral of the analytic function and path is any closed path, then answer will be 0 for m is not equal to -1, and if m is equal to -1, then answer will be 2 pi iota. Now remember this one here, if c is equal to C is unit circle or C is any arbitrary path. Say for unit circle or for any circle, we discussed this theorem in the previous example, in the previous exercise, and in this example we discussed the same exercise, the same example for the arbitrary closed path. In the previous one we discussed this one for the स्पेसिफिक सर्कल, राइट. मतलब लास्ट टाइम आपने इसको एक स्पेसिफिक सर्कल के लिए किया था, अब आपने इसको एक आर्बिट्रेरी पाथ के लिए भी कर लिया और दोनों के लिए सेम रिजल्ट आ गया, राइट. अब बस ये है कि जब भी आर्बिट्रेरी पाथ आए तो आपने उसके अंदर खुद से एक रेडियस, एक सर्कल सम रेडियस का सेट कर लेना, राइट. नाउ द प्रॉब्लम सेट 13.2. Verify Cauchy integral theorem. Cauchy integral theorem क्या है? The Cauchy integral theorem is if the function is analytic and path is closed, then that answer always equal to 0. This is the Cauchy integral. We want to verify it, means we want to prove it by path. अब by path से solve करेंगे और by path भी ये 0 आ जाएगा तो ये verify हो जाएगा, ठीक है. जैसे for the first one, you have this circle 1 plus iota here, -1 plus iota is here, -1 minus iota, and this one is 1 minus iota, and the given as find the integral of this z square. Z square is an analytic function, and the boundary of the along the boundary of the square, and the boundary of the square is given by, and the direction is counterclockwise, means this direction, right. Now you want to find, now first consider the path AB, this path. In this path only x vary and y is constant, y is minus iota, and x vary from -1 to 1, right. So y is minus iota, x vary from, x is t, so this is the equation of this line, and x is t, so t is equal to x, -1 to 1, t lies between -1 to 1, and z dot is equal to 1, and f of zt is equal to z square. Z is equal to z, t minus iota means t minus iota ka square, and t minus iota square, after simplification you get this one, and the limit is -1 to 1. So integral AB is given as this one. Simplify, integrate, you get one answer. You get answer -4/3. Similarly, now consider the second part BC, where x is fixed 1 and y is vary from -1 to 1. So z is equal to x plus iota by x is 1, y vary between -1 to 1, so consider y is equal to 3. This is the parametric representation. Z dot t, similarly find the answer along that path, that is equal to 4/3 iota, then find along CD, then find along DA, and when you find all the integration of the function along all the paths, then sum up of all these paths, then what is the result we see here. Now integral along the closed path, that is a square, right, and along one path -4/3, along second part +4/3, along third part 4 iota by 3, and along the fourth part -4 iota by 3, and cancel all these and you get answer 0. means Cauchy integral theorem verify. ठीक है, यहाँ Cauchy integral theorem वेरीफाई होगा, पाथ क्लोज था, फंक्शन एनालिटिक था, सो आंसर विल बी 0. आप डायरेक्ट भी लिख सकते हैं, इसका मतलब ये आपने वेरीफाई किया, अगर बाय पाथ भी करें तो आंसर 0 ही, राइट. नाउ द सेकेंड वन, now we consider that the integral of 1 over z square plus 4. Now this we want to find integral of this one, right. Integral of along this path. This path is the circle of center 2 and radius 2, and this path is the circle of center 2 and radius 3. Now you see that how can you find path is closed, this is a closed path, this is a closed path, and this one is analytic except the point ±2 iota. When you put this one is equal to 0, then z is equal to ±2 iota. The question is, can we conclude that integral of this one, क्या आप बता सकते हैं कि integral of this one taken over this one and this one is 0? Directly, can you directly tell about this integral? Integral of this function is equal to 0 along these paths. First we discuss these paths. This is the path of the circle with radius 2, center 2. with center 2, radius 3, and the path is just like S. This one, this is the figure. This is a figure of that. This is a circle of center 2, radius 2. So means you draw the circle of this one, and when center 2, radius 3, then you get this one. And you know that the function, that given function is not analytic at plus minus 2 iota. Within this circle, 2 and 2 iota and minus 2 iota lie outside this smaller one. So means for integral of the function along this path will be 0. आपने कंक्लूड कर दिया कि इस पाथ के लॉन्ग इंटीग्रल 0 है, क्योंकि इस पाथ के अंदर फंक्शन हर पॉइंट पे एनालिटिक है, राइट? इसकी बाउंड्री पे भी और इस पे भी फंक्शन सिर्फ एनालिटिक इस पे नहीं है 2 एयोटा एंड माइनस 2 एयोटा. फंक्शन इज नॉट एनालिटिक एट 2 एयोटा एंड माइनस 2 एयोटा विच लाई इन द सेकेंड सर्कल हुज रेडियस इज 3 एंड सेंटर इज 2. देखो रेडियस, ये 3 रेडियस है. This is on 3, this is on, and I lie on the boundary of this one. So means we conclude 0 into answer of the integral is 0 along this path, along z minus 2 modulus 2, and along z minus 2 modulus 3 is not equal to 0 because singularities lie inside or on the boundary, right? इस फिगर को गौर से देखें, इसको फिर आप बना लीजिएगा वहाँ पे, इससे आपको पता चल जाएगा, ठीक है? सो मीन्स ये देखिए मैंने करके दिखाया हुआ है, यहाँ सब लिखा हुआ है. इसके बाद जितने भी इसके क्वेश्चंस हैं सब सॉल्व हैं. आपने सारी एक्सरसाइज सॉल्व को देखना है. अगर कोई प्रॉब्लम हो जाएगी तो हम डिस्कस. मीन्स ऑल द क्वेश्चंस आर गिवन इन द हैंड आउट्स इन द सॉल्व फॉर्म. इफ यू हैव एनी प्रॉब्लम देन वी कैन डिस्कस ऑनलाइन लेक्चर्स, राइट?